So let's find out the metric representation of kets, bras and operators. Consider a discrete, complete and orthonormal basis set phi n which has infinitely countable set of vectors of Hilbert space. The completeness condition is satisfy this equation and the orthonormal condition is satisfied with this equation. So let's see the metric representation of kets. For a ket psi, it can be written as in terms of unit operator which leaves the ket psi unchanged, and from the completeness condition I cap can be written as this expression. So by ticking the ket psi inside we get summation n equal to 0 to infinity a n phi n, or ket psi equal to a1 phi 1 a2 phi 2 as a linear combination where the coefficient a n is equal to bra of phi n into ket of psi represents the projection of ket psi onto ket phi n. Also, these coefficients a n are complex numbers. So the kets are represented by column vectors. So as you can clearly see, bra of phi 1 and ket of psi can be given as a1, a2 till an. All these are complex number. On the similar analogy, bras can be represented by row vector which are given by bra of psi which is given by the row vector which has elements bra of psi into ket of phi 1, bra of psi into ket of psi 2 till bra of psi into ket of phi n. Now taking the complex conjugate we get phi 1 psi conjugate, phi 2 psi conjugate till phi n psi conjugate. Now we know phi 1 psi is given by a1. So phi 1 psi conjugate can be given as a1 star which is a complex number. So on a similar basis we can see that bras can be represented by a row vector which has a complex conjugate of our complex number a1. Using the previous two relationship, we can see that bracket of psi and phi can be written in terms of product of row matrix a1 star a2 star an star into column matrix b1 b2 till bn, which can be given by this expression where bn is the projection of phi on phi n and an is the projection of psi on phi n, where phi n's are our basis vector. One more thing is to note that our ket is normalized when our norm of psi is equal to 1. If psi is not normalized, we need to multiply it with a constant a which is the normalization constant, such that bra of a psi into ket of a psi will give you mod square of a which is our normalization constant into norm of psi, and from this we get our normalization constant as 1 by root under norm of psi. Now let's see the metric representation of operators. Consider a linear operator a cap. Now we can write a cap as I cap into a cap into I cap. As we know, our unit operator leaves our operator unchanged. So from the completeness condition, I cap can be written in terms of our basis vectors, and solving this expression we arrive at this equation where a and m is given by bra of phi n into a cap into ket of phi m, where a and m is our matrix element of our operator a cap. Here the operator A is represented within the basis set phi n by a square matrix which is given by this n cross m matrix, where A and m is the matrix element of our operator. So in summary we can conclude that kets are represented by column vectors, bras are represented by row vectors, brackets are nothing but our complex numbers, and our operators are represented by square matrices.